on to our second video, and this one is on subtracting integers. So we've already learned some rules and how to deal with adding integers, and now we're going to throw subtraction into the mix. So our essential question kind of sums it up. How is integer subtraction similar to integer addition? You're going to find there's a lot that they kind of go together, or that we can use similar thinking in helping us out. So a quick review. If you remember back to adding integers, if I added a negative number, I went to the left of my number line. If I added a positive, I would go up. I would go to the right of my number line. Well, think about subtracting a positive number, something you've done since elementary school. If I subtract 5 from something, doesn't my total go down, meaning I go to the left? So subtracting a positive number moves to the left, goes down on the number line, just like adding a negative does. Okay? Those kind of make sense. The next one's a little tougher. Say I'm subtracting away a negative amount. So think of it as you owe mom $5. So that's kind of like a -5. You owe her money. But she says, you know what? You did so good at your soccer game this week, you don't owe me that $5 anymore. So she's subtracting away the debt that you owe her. Well, didn't you just gain that money back? You kind of, the amount of money you have is now going up because you don't have to worry about paying her that money anymore. Okay? I know it can be hard to wrap your brain around, but when you're subtracting away a negative thing, you're getting rid of something bad that actually moves you in the good direction. Okay? So, same rules as before for adding and subtracting on a number line. First number tells you where to start, so I'm going to start at +8. I want to subtract a negative number. So normally a negative brings me down, but I'm getting rid of the negative. I'm subtracting the negative, so I'm going to move in the positive direction. I would move up 10 spots and end up at +18. Subtracting away that negative actually increased my total. Okay? Next one, 11 minus 15. Okay? So you already know how to subtract. You've got an idea of what this is going to look like. But I'm going to start at 11, and I'm subtracting a +15. So I'm going to go down by 15. Sorry, not the straightest line. And I'm going to end up at -4. I subtracted away more than I had. I took more than my 11, so I ended up into the negatives. So let's see one more. -7 minus -5. So I'm going to start with my first number at -7. But again, I'm subtracting a negative number. Subtracting a negative. Those two negatives kind of cancel each other out and turn me back into the positive direction. So I move up 5 spots and end up with an answer of -2. Okay? This last one is kind of the hardest one. You're dealing with a negative, you got another negative, and somehow it moves closer to being a positive. Okay? But with some practice, you'll start to get a little bit more comfortable with it. But here's another way of tackling the problem. So say we had the problem 8 minus +5. We all know we're going to get 3 as an answer. So think about the problem 8 plus -5. Notice how I still get 3 as an answer. Or say I do -6 minus 9. Well, -6, and then I go down by another 9. That's going to be a -15. But what if I did -6 plus -9? Well, I'd still get the same -15. So what I want you to notice is, in each case, the first number in my problem stayed the same. But instead of subtracting, I added. But what happened to that second number? So if I switch subtraction to addition, and if I switch the sign on my second number, I get the exact same answer. Here, first number stayed the same. But I switched subtraction to addition, and I flipped the sign of my number. So instead of a 9, it became a -9, and I still got the exact same answer. So that's the key to using our rule. Instead of having subtraction, we're going to rewrite it as adding, but the next number becomes its opposite, adding the opposite. And here's the idea behind it. Oh. Why learn a whole new set of rules for subtraction when we could just quickly rewrite it as an addition problem, and we can just use the rules we already just got good at? So the idea is the first number in the problem stays the same, just like we did here. Subtraction becomes addition. And the second number becomes its opposite. Okay, from our examples we found that if I make both of those changes, I still get the same answer either way. So why not make it into a problem I'm comfortable with and don't have to worry? So here's how I kind of scan through a problem. I leave the first number alone. Don't care if it's positive or negative, but anytime I see subtraction, I'm going to change it to addition, and the very next number becomes its opposite. It was negative, now it's positive. Then I go ahead and add negative 5 plus positive 13. They have different signs, so the positive is going to win because it's bigger. 13 minus 5 is 8. I just use the same rules I've always been using for adding integers. 7 minus 18. First number stays the same. Subtraction becomes addition. The next number always becomes its opposite. So I always say the phrase adding the opposite. It reminds me that two things need to be happening in that problem. 7 plus negative 18. In this case, the negative is going to win. 18 minus 7 is 11. In a larger problem, avoid the temptation of just changing everything in the problem. It's always the subtraction and the number right after it. That's all that changes. So negative 6 stays the same. Subtraction becomes addition. The next number switches to its opposite, in this case, negative 11. But this one was a plus 5. I don't want to change that because I like addition. The whole point is to write everything as addition so we don't have to try anything, or we don't have to learn any new rules. So once it's addition, leave it alone. Negative 6 plus negative 11, same signs, add them together and keep the sign. Plus 5, different signs, subtract. Take the sign of the bigger number. 17 is bigger than 5, so my answer is going to be negative 12. So keep saying that phrase, adding the opposite. Subtraction becomes addition, and the next number becomes its opposite. So let's try some of these real quick. First one stays the same. Subtraction becomes adding the opposite. So negative 18 plus negative 19, same signs, add them together and keep the signs. In this case, I would get 37, negative 37. 24 minus negative 15. First number stays the same. Subtraction becomes addition. And I switch the sign on the second number. Instead of negative, it becomes positive. Here they have the same sign, so I'm just going to add them together and keep the sign. Notice the next one. It's addition, so don't change anything. Just leave it alone and go ahead and add. Negative 7 plus negative 8, same signs, add and keep my sign. 64 minus 88. Well, 64 plus negative 88. I switch it to adding, and I switch the next number to its opposite. Here they have different signs, so the negative is going to win. And then I subtract 88 minus 64 is 24. So I get negative 24. Okay, next one, these longer ones, be careful. Only change the subtractions and only change the numbers that come right after it. So negative 4 minus, so it becomes plus, 7 becomes negative 7, adding the opposite. Here I've already got addition, so I'm going to leave it alone and leave my 16 alone. Negative 4 plus negative 7 is negative 11. Plus 16, different signs, subtract. 16 minus 11 is 5. And the positive was bigger, so it's going to stay positive 5. One last one. I just kind of scan across the whole problem. Anytime I see subtraction, I change it to adding the opposite. And then I keep going, adding the opposite. Now I come back and I can do the problem. A nice thing to do in a problem like this is, with addition, you can add them in whatever order you want. So maybe I add my two negatives together. Same signs, add them together and keep the signs. So I get negative 59. Here, same signs, add and keep. So I get 53. And then I add those two pieces together at the end. 53 plus negative 59. The negatives are bigger, so it's going to stay negative. 59 minus 53 is 6. And there you go. Hopefully that makes sense with subtracting integers.